Imagine a device that can safely measure the immense currents flowing through power systems, ensuring our homes and industries run smoothly. Welcome to the world of current transformers. A current transformer, or CT, is a specialized instrument transformer designed to step down high currents to a manageable level for measurement and protection. In essence, CTs are the unsung heroes of electrical systems, converting high-voltage currents into low-voltage currents for safe and accurate monitoring. The primary winding of a CT is connected in series with the high-current circuit, while the secondary winding connects to measuring or protective devices. When AC flows through the primary winding, it induces an alternating magnetic flux, which in turn generates AC in the secondary winding. This induced current in the secondary winding is inversely proportional to the current in the primary winding, making it a crucial tool for accurate current measurement. But what happens if the secondary winding is left open? The unopposed primary MMF creates an abnormally large flux, leading to core loss and potential insulation breakdown. To avoid this, the secondary winding must always be closed when the primary is conducting current, ensuring the transformer's safety and accuracy. The construction of a CT involves primary ampere turns, a core, windings, and insulation, each playing a vital role in its functionality. The core, made from materials like silicon steel, is designed to have low iron losses and high permeability, ensuring efficient operation. The primary winding, often a single turn, carries the full load current, while the secondary winding, with many turns, connects to meters or other devices. Insulation, provided by varnish and tape, is crucial for high-voltage applications, protecting the windings and ensuring reliable performance. CTs come in various types, each suited for specific applications. Indoor CTs are used in low-voltage circuits and come in wound, bar, and window types. Wound-type CTs have two distinct windings on a magnetic steel core, offering high precision and primary ampere twist values. Bar-type CTs use bars for the primary and secondary cores, with the primary bar being a crucial component for accuracy. Window-type CTs, available in solid core and split core configurations, allow the primary load current to pass through an opening in the core. Outdoor CTs, used in high-voltage circuits like substations, come in gas-insulated and oil-filled varieties for insulation and cooling. Bushing CTs, similar to bar types, have the secondary and core near the primary conductor, often used in high-voltage circuits for relaying. Portable CTs, including split core, clamp-on, and flexible types, are used with high-precision ammeters and power analyzers for accurate measurements. The phasor diagram of a CT shows the relationship between primary and secondary currents, voltages, and the main flux, crucial for understanding its operation. CT specifications include current rating, turns ratio, accuracy class, burden, frequency range, insulation level, thermal rating, knee point voltage, and phase angle error. Errors in CTs, such as current ratio error and phase angle error, can affect accuracy, but understanding these helps in selecting the right CT for the job. CTs are essential for various applications, from measuring electricity in power plants to providing overcurrent and fault protection in electrical equipment. They play a vital role in energy metering and billing, ground fault detection, motor and generator protection, and power quality analysis. In industrial automation and control systems, CTs are used for current sensing, relay operation, and monitoring electrical loads. In renewable energy systems, CTs help monitor and control electrical currents, ensuring efficient and safe operation. When using CTs, precautions are necessary, such as never open circuiting the secondary and providing oil cooling for high voltage lines. The advantages of CTs include galvanic isolation, high accuracy, wide dynamic range, low insertion impedance, and the ability to handle high fault currents. CTs provide a proportionate reduced current output, enabling multiple measurements from a single primary conductor and enhancing system reliability. They can be easily integrated into existing power systems, suitable for both AC and DC applications, depending on the design. Current transformers are standardized at 5A secondary current, ensuring consistency and reliability across various applications. So, the next time you flip a switch or power up a device, remember the current transformer working silently in the background, ensuring everything runs smoothly. Stay powered, stay safe.